Hello everyone, welcome to day 15. We'll move to the next question. Search in rotated sorted array. There is an integer array num sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly left rotated at an unknown index k such that resulting array is okay, so the first element is in somewhere in the middle and it is rotated. For example, this might be left rotated by 3 positions, so this will become 0 1 2 and then 4 5 6 7. Okay, given the array nums after the possible rotation and a target, return the index of target if it is in nums or -1 if it is not in nums. You must write an algo in log and return a runtime complexity. Okay, the numbers can be positive and negative. All numbers are unique. Numbers are in ascending order. That means it's already sorted, and target could be anything. Okay. The brute force approach for this question would be that we start iterating over this array and we can simply search the element in log n time. So we just simply write a for loop and check with each element. Now coming to log n solution, that means we need to do a binary search in this. So for that what we can do is, and let me take one more variable. Let's do like this: 1 2 3 4 5 6 7. Okay. So we need to find a target, the position of target in this. That means we need to find 0 in this. Target is 0. Let's say if target is 3, which is in the next question, we need to find the position of this 3. So for that, if we directly use binary search, what will happen? Once we check with the middle element, we won't be sure that if 3 is present on this side or this side, because what if it's rotated from here, then 3 will be before 2 and that is not the correct result. So in order to do this, we somehow need to, okay, one thing is that this array can be divided into two parts. One part is this and the other half is this, and both of them are sorted, right? So even if it's rotated, in this example this is the first half and this is the second half and both are sorted. So if somehow we can find the element from where it is rotated, I mean if somehow we can find k from where it is rotated, in this case it is 0, then we know. So if we can find the position of 0, then we can check if target, then we will be sure if target is present in this half or other half, right? So for that, this will be the smallest element in this array. So basically with binary search, we need to find the smallest element of this array, right? So what we can do is, we can do the binary search, okay, and what we can do is, if we take a low and high, this is high, this is low, and this is high, and we can check that if this value, the high value, is bigger than low, that means it is still rotated. So 0 will be present in and this is mid is, let's say, 2. So in that case we will we also need to check the mid, right? Because it is still possible that 0 is present on this half. Right, like in this case, if we get 7 as mid, 4 as low and 2 as high, so if 7 is the mid, okay, so then we can check that if 7 is greater than low, that means it will be present in the other half. And if the 6 is greater than 2, if this 4 is less than 7, that means this is already sorted and the lowest element will be in this half. And in this case, if 6 is greater than 1 or 2, which is the middle element, that means this is not sorted and the lowest element will be in this half. So if int let's take n first. Oh, I need to write it in Java. 1 second. So int n equals to nums dot length, and we will take a variable low equals to 0 initially, and int high equals to -1, and int mid. We'll run the loop while low is less than equals to high, and we can check and we calculate the mid equals to low plus high minus low by 2. Okay, so we have got the middle element, which is 2. Now we can check if nums low is greater than nums mid. If nums low is greater than nums mid, so it is greater than this also, then it should be low is greater than mid. That means the result is in this half. So in that case, what we will do is low will become mid. Else if it is greater, if 7 is the mid, then 6 is low. Let's take this example for other case. Now in this case, if nums low, oh, that was the correct example. So in this case it is greater than 7, nums low is less than, in this case it is greater, nums low is greater than mid, then we need to search in this half only. So high will be updated, right? High will become mid. So high will become mid, because if this is mid, then we need this value in the search space. So high will become mid, not mid -1, otherwise we will lose this 0. Else is this case, that if it is greater than, if nums low is less than mid, if it is less than mid, then we will make low as mid plus 1. We can go here. So low will become mid plus 1. Also we can do one more optimization. What if somewhere while doing the binary search we find the target? So we don't need to further do anything. Let's take one more thing, that if nums mid is equals to target, then return mid, that is the position. Okay, and low is mid plus 1, this is fine. And at the end, what will happen is high will contain and low and high both will contain the correct result. So we can do so that is the lowest element. So int lowest is the mid value or high value. Now we need to again do a binary search, but which the question in which part? So for that we can, if target is 0, that means okay. So if target is greater than the first element, that means it is in the first half, otherwise it's in the second half. So we can check if, let's write a other function, because we need to do binary search 2 times, for one for this part and one for this. So let's write a separate method for doing the binary search. Binary, let's take a int binary search. I'll write it recursively. So int nums int I int j, let's take low and high, low int high and int target, and we can do int mid equals to low plus high minus low by 2 and we can check if nums mid equals to target, then this is the position. Also we need to check if nums mid is less than target. So if it's less than target, that means mid is less than target, that means we need to search in the later half. So low will become mid plus 1, or we can do return binary search nums. Low will become mid plus 1, high will remain same, and target. Else will return binary search nums low high minus 1 and target. And also we need to write the base case. So base case is if low is greater than high, then low is greater than high, then return minus 1. Now after this we need to check if it is the target is greater than this element, first element. If target is greater than first element, target is greater than nums 0, then we need to search in first half. So return binary search nums, first half is 0 and last element is lowest minus 1 and target. Else we need to greater than or equal to, else we need to return binary search nums, first element will be lowest, then n minus 1, then target. Let me run this code. Okay, output is -1, expected is 4. I'm just a little confused over this thing, that which value will contain the pivot, if it's mid, low or high. Otherwise this solution is fine. Only this case I'm output is -3, in this also -3. First case, this is the expected case which is failing. And let me print the lowest dot out dot print ln low, high and mid, low plus high plus mid. What mid is not initialized? Seven, 6, 6. Low is 7, but that is not correct. It should be here. How come? Zero, 1, 2, 3, 4. Index should be 4. What is happening? Low is 0, high is n-1, mid is nothing. Low is less than equals to high, this is correct. So mid will become low plus high minus low by 2. Now we are checking if this mid is mid. Then we are checking if mid is less than low. If mid is less than low, let me do a dry run. So in this case low is 0, high is n-1, and kitna iska 1 2 3 4 5 6 7, so high is 6. Okay, now mid will become 0 plus 6 minus 0 is 6 by 2 3, 3 plus 0 is 3, mid is 3. Now we are checking nums mid is 0 1 2 3, this 7. If 7 is target kitna hai hamara? Target is 0. 7 is not 0, so we are checking if nums low is greater than nums mid. Nums low is 4, nums mid is 7, so it is not greater. Not greater तो हम else में आ जाएंगे और low update हो रहा है, so low will become mid plus 1, that means 4, and high will remain 6. Mid will become 6 minus 4 is 2, 2 by 2 is 1, 4 plus 1 is 5. Now we will check nums mid तो 0 है नहीं, यहाँ पे check करेंगे nums low is 4, 0, 1, 2, 3, 4. Nums low is greater than nums mid? No, it is smaller. This is not correct. Because even in this case nums low is, if we are searching in this, nums low is less than mid, so low will become mid plus 1, so we are shifting lowest is not correct. Instead of comparing it with low, we should compare it with high, the mid value, I think, because let's say we got the mid, in this case 7. If 7 is greater than last wala value, so then it means we have got one of these which is greater than the last wala value. That means we should shift to the other half. Right? Otherwise we should otherwise what is the other case? In this, if we have got any one of these as mid, नहीं high से compare कर रहे हैं ना, so if we get a smaller value, that means we are in correct half as mid, and if we get a greater value, then we are in incorrect half. I think we should compare it with high. That will give us the result. So if nums mid, let me remove this first. If we'll do nums mid, if it is greater than nums high, then we need to shift low, right? Because if nums mid is 7, if it is greater than 2, that means we need to shift in this half, so we need to update low will become mid plus 1, else we need to do else in this case, if 1 is there and if nums mid is less than this, that means we need to shift high and move to this part. So else high equals to mid, right? Let's see. Wait. Time limit exceed why? Hmm. Hmm. But is it going to work for other cases? 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's see 10, and target is 3. What about target is 8? It is working. Okay. But in this case you see low is 2 and high is 1. This is correct. Let's submit. You see, so 1 and 3, target is 3, low we are getting 0 0. That means यहाँ तक तो it's correct ना, low is at 0, sorry, high is at 0, so this is fine. Let's see, this, and we need to find 3. Let me print lowest as well. Lowest is low. Lowest. Lowest is at 0. This is correct. Now if target is greater than nums 0, target is greater than num 0, that means target is greater than 1. That is correct. So we are searching in other half. We are searching from 0 to lowest minus 1. Lowest minus 1 is minus 1. So that means it is not working in cases where it's already sorted. Wait, target is greater than nums 0. So it should search in first half. First half is 0 से लेके lowest minus 1. हाँ, this is correct, but it will not work in already sorted arrays. So for that, what we can do is we should do one more case, that if lowest is 0, that means it's already sorted, then return binary search and 0 से लेके n minus 1 में, else if cool. It's a very bad solution, is it? But at least it works. Let me see some solutions. When an array is rotated and sorted, one part is sorted, other part contains the pivot, the rotated part. Using the observation, we can decide to which side eliminate to an index mid. Either left side half is sorted or right half is sorted. If the dark line is sorted half, we move forward to the, otherwise we move towards the unsorted half. Correct. So this is the same thing. But they are doing it in same loop. We do the start, the end, we taking mid. If nums mid is target, then return mid. This is fine. Now if left part is sorted, nums mid is greater than nums start. Acha, we are moving both the parties. End and start both. That is a clever solution, right? Let me see a few more. ये वाले में they are doing 2 searches. It's the same thing. They are given the same solution. Same thing. Fine. Next question is sorted, search and rotated sorted array 2. Some modified form of the same question. There is an integer num sorted in non-descending order. Before being passed to your function, nums is rotate unknown pivot. Same thing such as in resulting array is this. For example, this must be rotated for 5 by this given an array. After the rotation, target return the target if target in nums, or false if it is not in nums. Okay, true false करना है बस. You must decrease the overall operation steps as much as possible. The only difference in this case is we have multiple, we can have duplicates now. Well, I think previous solution will work on this also. We just need to return true and false. Is this solution not going to work for this? Let me see. Such. In this case, we return true. If mid is there, we return true. Then we need to return false and return true. Will it not work? Boolean. I think it will not work in the other cases, like the other solutions they were saying na. Maybe it's not working on those solutions. Okay, it's not working. Fine. What is it? Target is 0. We are saying false, but it is true. What? Oh, okay. Even after rotation also the first element could be the same as last. Makes sense. Okay, we'll have to modify this a little. We'll do this tomorrow. Cool.